Earth Systems 3209, Unit 4, The Forces Within Earth. References for this unit can be found in Chapters 4, 15, 16, and 19. Also in Appendix A and B of the Curriculum Guide. Unit 4, Topic 5.3. This topic will look at intraplate volcanism and hotspots. The focus will be on defining a hotspot and identifying two tectonic environments associated with hotspots and providing an example of each. Let's first look at plate boundary volcanism. Volcanoes are associated with two or three different types of plate boundaries, these being convergent plate boundaries and divergent plate boundaries. Very little volcanic activity is seen at transform fault boundaries. Volcanism associated with plate tectonic activity are found in three areas along the Earth: at ridges, subduction zones, and the interior of tectonic plates. This presentation will focus on number 3, the interior of tectonic plates. Text references for this topic can be found on pages 543 to 544 and also 121, 122. When we look at intraplate volcanism, this type of volcanism is produced by rising hot mantle material called hotspots. Hotspots can be found under continents and also under the ocean floor. When hotspots or magma sources are found within tectonic plates, it is called intraplate volcanism. And intraplate volcanism occurs in two areas. That is, beneath the oceans, such as the Hawaiian Islands. Volcanism that's produced underneath the oceans produce basaltic magma sources in the ocean crust. The second place where intraplate volcanism can occur is within continental plates. An example of this is in Yellowstone National Park. These hotspots produce granitic magma sources within the continental crust. Let's look at the first location where intraplate volcanism occurs, and that is beneath the oceans. Hotspots within the mantle cause magma to move upwards and flow onto the ocean floor, forming shield volcanoes and volcanic islands. One example would be the Hawaiian Island chain that's located within the Pacific Plate in the middle of the Pacific Ocean. The second place where intraplate volcanism occurs is within continents. Hotspots within the mantle cause magma to move upwards and flow out onto the continental surface, forming volcanoes and lava plateaus. These features can be seen in Yellowstone National Park, which has this type of volcanism. When we look at volcanism on tectonic plates moving over a hotspot, they are associated with plumes of heat in the mantle. They form localized volcanic regions in the overriding plate, and these localized volcanic regions are called hotspots. If we look at the series of 3 diagrams below, we can see the evolution of a hotspot. In the first diagram, we see heat sources from the core moving upwards. This rising heat plume would produce a magma head, which would eventually move to the base of an oceanic plate or a continental plate. In diagram 2, we see the heat source accumulated underneath the oceanic plate in this case, which forms a hotspot. The hotspot will extrude through the oceanic plate, and it will spill on top or on the surface of the ocean floor and would form flood basalts. Eventually, these would migrate as the hotspot is stationary in the mantle, and the ocean floor moves over this stationary hotspot into a series of volcanic islands. And these volcanic islands are evident today in the Pacific Ocean, where we see a chain of volcanic islands that resemble the Midway Islands, which eventually progresses into the Hawaiian Island chain. Let's look at some examples of hotspots. Example number 1. It says, using plate tectonics, explain why the Hawaiian Islands vary in age and amount of volcanic activity. The answer to this question states that the Hawaiian Island chain formed as a result of the Pacific Plate moving over a hotspot located in the mantle beneath the Pacific Ocean. The oldest volcanic islands are located farthest from the hotspot and has little to no volcanic activity, whereas the closer you get to the hotspot, the younger the volcanic islands are, and the greater the amount of volcanic activity. For example, the island of Hawaii is presently positioned directly over the hotspot and experiences volcanic activity on a regular basis, and this is evident in the eruptions that occur on a regular basis from Kilauea, the active volcano on the island of Hawaii. Example 2. The Hawaiian Islands are located where the Pacific Plate is doing which of the following? And the answer to this question is the Hawaiian Island chain is located where the Pacific Plate is migrating over a stationary hotspot. Because the stationary hotspot is not moving, the volcanic islands will tend to get older the farther away they go from being over the hotspot. And right now, the island of Hawaii is positioned over the hotspot and receives magma from the hotspot. So the answer to the first question is C, migrating over a hotspot. The second question reads, which type of volcanic eruption resulted in the formation of the Hawaiian Islands? And the Hawaiian Islands is a direct result of a hotspot that is located within the Pacific Plate. And as the Pacific Plate moves over this hotspot, we get a chain of volcanic islands known as the Hawaiian Islands. So the answer to this question, which volcanic eruption resulted in the formation of the Hawaiian Islands, the answer would be B, hotspot eruptions. Your turn. Take the time and complete the following question. You can pause the recording now to prepare your answer, and the answer to the question will be on the following slide. Question reads, with the aid of a labeled diagram, explain how the Hawaiian Island chain formed. So, if you read the question directly, we need to use a labeled diagram and explain how the Hawaiian Island chain forms. So your answer should include the following. It should include a diagram, such as the one here to the right, which shows the migration of an oceanic plate over a hotspot, and also shows the progression of different volcanic islands as you move away from the hotspot. The older volcanic islands will be located farthest from the hotspot, and the youngest volcanic islands would be located directly over the hotspot. And in this case, that would be Hawaii, the island of Hawaii. So your answer should read something as follows. The Pacific Plate moved over a stationary hotspot, forming new volcanic islands directly over that hotspot. The older volcanic islands move with the Pacific Plate and travel farther away from the hotspot with each passing year. Over a period of time, a chain of volcanic islands form. The older islands are no longer fed by the hotspot and therefore become dormant or extinct or inactive volcanic islands, whereas the islands that are close to the hotspot and directly over the hotspot would still be looked at as active volcanic islands. Let's look at a summary of the points covered in this presentation. This presentation focused on intraplate volcanism, which focused on the formation of a hotspot and volcanic islands which result from that hotspot. So the definition of a hotspot included: a hotspot is a concentration of heat in the mantle capable of producing magma that extrudes onto the surface. There are two tectonic environments that are associated with hotspots and intraplate volcanism. The first environment is beneath the oceans. As such, with the Hawaiian Islands, if a hotspot is located beneath the ocean, it produces basaltic magma sources in the oceanic crust, which rises and forms volcanic islands which are rich in the basaltic magma composition. Number 2 is within continental plates, such as Yellowstone National Park. If a hotspot is positioned beneath the continental plate, the magma will rise through the continental plate, melting the plate as it rises through, and it will produce granitic magma sources in the continental crust. And these will form very rich felsic magmas that produce granitic rocks that are found in the volcanoes. The rock that is produced on the surface as a result of these granitic hotspots would be rhyolite. So these are the main points that were discussed in this presentation.